So for this system, we're going to start off by using substitution to try to go from our 3 variables and 3 equations down to 2 variables and 2 equations. If you look at it, you could do elimination, right? You could do elimination with the x's here. We can multiply this by like a -3 and it would cancel with there. You can multiply it by 2 and it would cancel with this one. Or you could do elimination with this y. You can multiply it times 4 and it would cancel. Multiply it times a -2 and it would cancel with that one. But just for the heck of it, we'll try to do a substitution here. And so with that being our method, we're looking for something with a coefficient of 1, and I'm looking at this y here. So what I'm going to do is I'm going to isolate this y. So I'm going to subtract 2x over to the other side. I'm going to subtract 6z the other side and divide by -1, or I could just add y over to this side and then add 4 back over that way. So either way, doesn't matter. In the end, I'm going to get y equals 2x plus 6z plus 4. And so now, since I know that y equals this, it equals this anywhere in the system because as a system, everything is kind of true at the same time, right? So I'm going to take this y equals 2x plus 6z plus 4. I'm going to plug it into all the other places where I see a y in the other 2 equations. And so I'm going to get 6x plus 4 times 2x plus 6z plus 4. Don't forget to include the minus 5z after you've plugged in for the y there. Right, so minus 5z equals -7. So make sure you do all your math correctly. You're going to get 6x plus 8x, and then you distribute, you're going to get plus 24z plus 16 minus 5z equal to -7. You're going to get 14x. I'm going to get a plus 19z. I'm going to subtract 16 over to the other side, and then I'm going to get, so what's that going to be? 23. -23. So there's my first equation. Now I'm going to plug the y equals 2x plus 6z plus 4 into this y here. So I'm going to get -4x minus 2 times 2x plus 6z plus 4. And I'm going to have a plus 5z equals 9. So we get -4x minus 4x again, minus 12z minus 8 plus 5z equals 9. So I'm going to get a -8x. When I combine that, I get a, -7z. So minus 7z. I'm going to add 8 to the other side, so I get plus 17. So this is my second equation in 2 variables of x and z. And so at this point, I'm going to rewrite it over here. I'm going to have 14x plus 19z equals -23. I'm going to get -8x minus 7z. Sorry, this should be equals 17. And so when you look at these, it's kind of like, these numbers aren't the best, either for elimination or substitution, right? I don't have any coefficients here that are 1. And so at this point, what I would do is, I guess I would do elimination if I had to. But as you can see, what it tends to happen more with substitution, I think, is that you'll get to a case like this where you get these kind of like uglier numbers. Usually elimination works better, at least in the history that I've had with it. But you can still do it, right? You can still do substitution to start off with. Sometimes it gives you something ugly like this, and sometimes it doesn't. But either way, we can still work it out. So I'm going to run over and get a calculator here. And okay, so which variable we're gonna go for? Let's get rid of the x's, I guess. So I'm gonna multiply this by 8. I'm gonna multiply this by 14. And so the new equations, I'll work on my calculator here. So 8 times 14, I knew that's 112. So I'm gonna get 112x, and then down here I'm going to get a negative 112x. 8 times 19 is 152 equals, that's going to be what, 160 plus 24 is, just making sure, 184. Yep, so negative 184, and then 14 times 7 gives us a minus 98. Sorry, that should be z. And then 14 times 17 is 238. So when I combine here, I'm going to get, so the x's cancel. 152 minus 98 is 54z. And then when I add these together, I can already tell what's going to happen. Just from the numbers of it, I'm going to get 54. So now I divide by 54 on both sides, and obviously z equals 1. I'm going to take z equals 1 here. I'm going to plug it back into one of these two equations and two variables. So let's go with that bottom one there. So I'm going to have negative 8x minus 7 times 1. Sorry, can't see that. Equals 17. Get negative 8x minus 7 equals 17. I'm going to add 7 to both sides. I'm going to get negative 8x equals 24. X equals a negative 3. Take the x and the z, plug it back into one of the original equations with 3 variables in it. And so let's go with the first one there, why not? So 2 times x was a negative 3 minus y. Actually, wait, what am I doing? Look at that. I could go ahead and plug it into this one. It's already solved for y. Make my life easier. Y equals 2 times, what was it, negative 3? Plus 6 times z, which was 1, plus 4. So y equals negative 6 plus 4, which gives us a y value of 4. So as an ordered triple, I'm going to have negative 3, 4, 1. That is the solution to the system. If I wanted to graph that, it would look something like this. Again, this is my x-axis, y-axis, and z-axis. I'm going to be going back here for my negative 3. So let's go back here, 1, 2, 3. I'm going to go over 4. 1, 2, 3, 4. So my parallelogram is going to be somewhere over here. And then from here, I'm going to go up 1. So I'm going to go up 1 from here, up 1 from here, up 1 along there. Go across, put the top of my box on there. And there it is in the back right top corner. That's where my point, negative 3, 4, 1 is going to be.